All right, let's take a look at review number 1. So this is number 1. And it says make a drawing for each problem, set up the trig ratio, and solve to the nearest tenth. So that's where you're entering your answers. Do not include the units. It'll just make it easier for us. So here we go. Number 1, a sledding run is 300 yards long with a vertical drop of 27.6. Find the angle of depression. So I'm going to put the ground. The vertical drop is 27.6. The run going down the hill is 300, so that's our hypotenuse. And we need to find the angle of depression. So remember, angle of depression is from horizontal coming down. So that's what we're trying to find. So we can transfer it down here. So basically we're trying to find theta. So I'm going to put my guy down here. And I'm going to label my sides. This is the opposite. This is the hypotenuse. So this looks like a job for sine. So the sine of I don't know is opposite on top of hypotenuse. So to find the missing angle, we need to do the inverse of that. So let's pop it in here. Second sine, 27.6 divided by 300 is 5.278. So nearest tenth, we'll call that 5.3. Next problem. Number 2, a doctor is using a treadmill to assess the strength of a patient's heart. He sets the 48-inch long treadmill at an incline of 10 degrees. So this would be flat. He's going to set the treadmill at 10 degrees, and it's 48 inches long. And we need to make it 90, and we need to find how high is the end. So we need to find h. So again, put my guy over here. It looks like we have opposite, we have hypotenuse, so another job for sine. A little bit differently though, because we know the angle. So opposite on top of hypotenuse. Slap a 1 under there. Cross multiply, 48 times the sine of 10 degrees, 48 times sine 10 equals, I'm getting 8.335, so we'll call that 8.3 inches. You don't need to put the inches in there, so I'm just going to leave it off. All right, number 3, find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18-meter shadow. So we have a telephone pole that is 12.5, casts a shadow on the ground. So this is my shadow down here, and that's 18. And we need to find the angle of elevation. So we need this angle right here. So put my guy down there, opposite, adjacent. That's a tangent problem. Tangent of I don't know is opposite on top of adjacent. So to find the missing angle, we need to inverse that thing. So second tan, 12.5 divided by 18, bam, 34.7778, rounding to the nearest tenth. We're looking at 34.8. Checks out. Let's move on to number 4. All right. So a person in a hot air balloon is looking down with an angle of depression of 36 degrees at their car 75 feet away, straight line distance. How high is the balloon? So depending on how you set it up, kind of put the car over here, and we'll put our balloon up here, and we're looking down at the car. We got a 90 here. Angle of depression is 36, so just be careful where you put that. That's really right there. So I'm going to transfer it down here. And the car is 75 feet away, straight distance. So the 75 is actually this hypotenuse here. So 75. And what are we trying to find? How high is the balloon? So I'm going to put my guy over here. We have opposite. We have hypotenuse. So let's use sine. The sine when standing at 36 degrees is opposite over hypotenuse. So shake and bake. 75 times the sine of 36. 75 times sine 36. 44.08, which will turn into 44.1. Boom. Looks good. Next problem. Student wants to know how high the flagpole is. Her eye level is 5.5 feet above. So I got a nice line here, so why don't I just use that for the ground. We got the kid. Flag. And from her eyeball, and she's 5.5, so actually I got to put the triangle right here. So this 5.5 is going to get added. So actually what we're going to do is we're going to find this part of the flagpole. We're going to call it X. And then H is going to be the entire distance of X plus the 5.5. So let's get X first. She's 36 feet away. And the angle of elevation is 25 degrees. So to get X, X is going to be the opposite. 36 is going to be the adjacent. So that's tangent. So tangent when standing on 25 degrees is opposite over adjacent. Slap a 1 under there. So 36 tan 25. 36 times tan 25. So X is 16.78. So we'll call that 16.8. But that's not the final problem. That's just X. So we have 16.8. So for H, we got to do 16.8 added to the 5.5 because the angle was from her eye. 3, carry the 1, that's a 2. So I'm thinking 22.3, bam. 5 for 5. Let's keep going. Wish these problems were a little bit further apart. I apologize, but whatever. We can do it. Person whose eyes are 5 feet above the ground is standing on the runway of an airport, 100 feet from the control tower. So, got the ground. We got the person. Eyes are now 5 feet above the ground. We got a big old control tower over here. This problem is probably not drawn to scale, but whatever. So eyeball to the top, horizontal line across, very similar to the last problem. 5 feet, 5 feet. So we're going to go after that X again. And then H will be X plus the 5. All right, so what do we have here? We got 100 feet from the tower. So 100 is the bottom portion. And standing on the runway of the airport, 100 feet from the tower. So I think the person observes an air traffic controller at the window of the 132 feet tower. So actually I started off a little bit wrong here. This is 132 feet for this person up here. So actually I need to take away that 5. So if this is the height of the tower, X is going to be 125. And we need to find the angle of elevation. So we need to find that. So it looks like we have the opposite. It looks like we have the adjacent. So let's try this. The tangent of I don't know is opposite over adjacent, which means theta is going to be 120, well, it's going to be inverse tan of that thing. So second tan, 125 divided by 100 is 51.34, which would be 51.3. And actually I screwed up a little bit because when I take away 5, this should have been 127. So tweak that a little bit, 127. So this would be a 127. So second tan, 127 divided by 100. And that's going to change it to, check that, 51.78, which will be 51.8 when it's all said and done. Sorry about the little screw up there. Number 7, a golfer is standing at the tee, looking up on the green on a hill. The tee is 36 yards lower than the green, angle of elevation. Find the distance from the tee to the hole. So here's the ground. And the green is kind of up here. And this is where our little flag is. We're trying to make it up there. And the tee is 36 yards lower. So this is the tee box. This is where the person is shooting from. So it's 36 yards lower. So that's our height. And angle of elevation is 12. Find the distance from the tee to the hole. So we're trying to find that distance right there. So I'm going to get rid of this kind of over here. We're golfing. So this looks like an opposite hypotenuse. This looks like a sine problem. So the sine of 12 degrees is opposite on top of hypotenuse. Gonna have to do a little division here. 36 equals d times the sine of 12. Divide by sine 12. Divide by sine 12. You gone. 36 divided by the sine of 12 is 173.150. So we'll call that 173.2. Money. Feels good when you're right. Next one, number 8. A ladder's leaning against the building. So I have the ground, I have the building, I have a ladder leaning there somehow. 78 degrees is the angle with the ground. Foot of the ladder is 5 feet from the building. How long is the ladder? So we need to figure out that. So if my person is here, this would be adjacent, this would be hypotenuse. That's a job for cosine. Cosine of 78 degrees is adjacent on top of hypotenuse. Another division problem. 5 equals the x times cosine of 78, which I'm going to divide by 5 divided by cosine 78. Bam. 24.04. So that's going to be 24.0. Yes, sir. Number 9. Almost done here. We got a person is sitting on a 30-foot pier overlooking the ocean. So I'm going to put the ocean down here. There's the ocean. We're on a pier. So let's just kind of draw that pier here. The person's eye level is 3 feet above the pier, so they must be sitting down, I'm guessing. Legs dangling over, or they're very short. He sees a whale surface in the ocean. My whale is going to be pathetic, so I'm just going to draw Oh my God, that's a horrible fish, but we'll pretend that's a fish. Angle of depression is 20. So my eyesight would be here. Depression to see the whale is going to be 20 degrees, which I'm going to transfer over there. How far is the whale from the eyes? Well, one thing I need to understand is that this height from the eye is going to be, we have the 30 from the pier, and then we have the 3 feet for the person. So our total distance over here, this total thing is going to be 33. And we need to find how far is the whale from the eyes. So we need to find x. We need to find the hypotenuse. So standing at the 20, if this is my reference angle, 33 is my opposite. X is my hypotenuse. We'll try sine of 20 degrees is opposite over hypotenuse. And we get 33 equals x times sine of 20. Another division problem. Man, they're loading us up with division problems. 33 divided by sine 20. I'm getting 96.485, which would be 96.5. Looks good. Finally, number 10. After flying at an altitude of 500 meters, a helicopter starts to descend when its ground distance from the landing pad is 11 kilometers. What is the angle of depression for this part of the flight? So this one seems a little bit weird of a setup. So I got my ground, and we got a helicopter. That's a pretty bad helicopter, but whatever. Distance of 500, altitude. So we're at 500. Starts to descend when it's ground distance from the landing pad. So this is going to be our landing pad. And the ground distance is 11 kilometers. Ooh, this one's kind of weird because we have kilometers and then we have meters. So we can't just use 2 random measurements. So we got to kind of tweak this a little bit. So to change kilometers to meters, we need to multiply it by 1,000, because kilo is 1,000. So I believe this would be 11,000 meters. Now we got meters talking to meters, and we need to find the angle of depression. So we got the horizontal, we got to the landing pad. We need to find this, which means we need to find that, which means we put our little dude down here, and we have opposite, we have adjacent. I think this is the tangent job. Tangent of the angle we're looking for, opposite over adjacent. It's going to be the inverse of that crap. So second tan 500 divided by 11,000 is, oh, that's not very big, 2.602. Oh, looks like it's right. 2.6 degrees would be the angle of depression. All right, hopefully this helps you get ready for the free response portion of the test. See you.